Welcome to your custom deep dive. Today we're cracking open some MIT OpenCourseware lectures on dynamic programming. I'm excited to see what we can unpack together.
Yeah, it's a technique that pops up all over computer science, and honestly, it can seem a bit intimidating at first.
But before we get lost in the weeds, what is it that you're hoping to get out of this deep dive? What kind of aha moments are we looking for today? For me, it's about going beyond just knowing the name dynamic programming. It's like, I get that it's about breaking down problems,
Right.
but I want to feel how that actually works in practice. Like, give me that light bulb moment where I can actually use it.
I love that. I think a lot of folks hear terms like optimization and algorithms and their eyes kind of glaze over. But when we can see how these techniques solve problems we actually care about, that's when things click.
Absolutely.
Yeah.
So to kick things off, the first lecture uses the Fibonacci sequence as a starting point.
Yeah.
0, 1, 1, 2, 3, 5, where each number is the sum of the two before it. Pretty straightforward, right?
Right. But even in this seemingly simple sequence, there's a hidden complexity. Imagine trying to calculate, say, the 100th Fibonacci number.
Yeah.
If you go the traditional route, you'd end up repeating tons of calculations. It quickly becomes a computational nightmare.
Okay, I'm starting to see where the inefficiency creeps in. You're essentially doing the same work over and over again.
Right.
But how does dynamic programming help us escape this computational trap?
This is where it gets really interesting. Dynamic programming swoops in with a clever trick. Instead of recalculating everything, we store the results as we go, creating a sort of lookup table. The next time we need a specific Fibonacci number, boom, we just grab it from our table instead of starting from scratch.
So it's like having a cheat sheet for the Fibonacci sequence. That sounds way more efficient. But how does this cheat sheet actually work in practice?
Think of it as building a pyramid. At the very bottom, you have your base cases. The first two Fibonacci numbers, 0 and 1. From there, each level of the pyramid builds on the previous one. To get the third Fibonacci number, we add the first two. For the fourth, we add the second and third, and so on. Each time, we store the result in our table.
Okay, I'm visualizing this pyramid of Fibonacci numbers.
Yeah.
But I have to ask, is it really worth the effort to build this table? Does it make that much of a difference?
The difference is huge, especially as you climb higher up that Fibonacci pyramid. Without dynamic programming, the time it takes to calculate each number grows exponentially, like a runaway train. But with our lookup table, it becomes a smooth, linear ride. The time it takes grows proportionally to the Fibonacci number you're calculating.
That's a pretty compelling visual. So we've gone from a runaway train to a smooth, predictable journey.
Yeah.
It sounds like dynamic programming is all about turning those exponential nightmares into manageable, linear problems.
Exactly. And this simple optimization can make a world of difference, especially when we start tackling real-world problems that involve tons of data and complex calculations.
Okay, this is all making sense. But so far, we've been playing in the theoretical sandbox of Fibonacci numbers.
Yeah.
What about those real-world problems you mentioned? Where does dynamic programming actually make a difference in our lives?
Let's shift gears and talk about a problem you probably encounter every day. Finding the shortest path.
Okay.
Imagine you're using Google Maps to get from point A to point B. You have a whole network of roads, intersections, traffic lights, maybe even some construction detours.
I use Google Maps all the time. I never really stopped to think about how it actually figures out the best route so quickly.
This is where dynamic programming algorithms come in.
Yep.
They're like the masterminds behind the scenes, working tirelessly to find you the most efficient path. Instead of getting overwhelmed by the entire road network, they break the problem down into smaller, more manageable pieces.
So it's like dividing a giant puzzle into smaller sections that are easier to solve.
Exactly. Imagine focusing on one intersection at a time. You figure out the shortest path to reach that intersection from your starting point. Then you do the same for all the other intersections, building a web of shortest paths.
Okay, so it's like finding the shortest path to each individual intersection, like solving little mini puzzles and then piecing them together to get the big picture.
That's the essence of it. And by combining these smaller solutions, you can ultimately find the shortest path from your starting point to your destination.
So dynamic programming is like a master strategist, breaking down a complex problem into smaller battles, and then using those victories to win the overall war.
I love that analogy. And what's remarkable is that these algorithms can handle incredibly complex scenarios with countless roads, intersections, and real-time traffic updates.
Yeah.
They're constantly recalculating, adapting, and finding you the most efficient route.
It's amazing how much computation is happening behind the scenes, and we just take it for granted. I'm starting to appreciate the invisible hand of dynamic programming in our everyday lives?
It's everywhere. Think about spell checkers, for instance. You mistype a word, and the spell checker magically suggests the most likely correction. How does it do that? By calculating something called the edit distance.
Edit distance. Is that like how many typos I made?
It's a bit more nuanced than that. It's about figuring out the minimum number of changes, adding, deleting, or substituting letters needed to transform one word into another. And guess what plays a key role in calculating this edit distance efficiently?
Dynamic programming, right? It feels like it's the answer to everything today.
You got it. It's like a linguistic detective, analyzing all the possible edits and finding the most plausible correction. So next time you see that red squiggly line under a misspelled word, remember the power of dynamic programming working its magic.
Okay, I'm sold. Dynamic programming is officially the unsung hero of my digital life.
Yeah.
But I'm curious, are there any other examples where it's used in surprising ways?
Let's dive into some less obvious examples from the lectures that might just surprise you.
One that really caught my eye was the bowling problem. Now, this isn't your typical bowling alley. Imagine you're at a carnival, and each pin has a point value. But here's the twist. Some pins have negative points.
Negative points.
Exactly. And you can only hit 1 or 2 pins at a time. The challenge is to figure out which pins to knock down to maximize your score. It's like a strategic puzzle disguised as a carnival game.
That sounds tricky. How do you even begin to figure out the best strategy? Is it even possible to guarantee the highest score, or is there an element of luck involved?
This is where dynamic programming shines. It helps us systematically explore different combinations of pins to hit, taking those negative values into account. By breaking down the problem into smaller decisions, should I hit this pin or those two?
Right.
We can build up a solution that leads to the optimal score.
So it's like creating a decision tree where each branch represents a different choice of pins to hit. And dynamic programming helps us navigate that tree to find the most rewarding path.
I love that visual. And what's fascinating is that this seemingly frivolous carnival game actually has real-world parallels. Think about financial investments. You have different options, each with potential gains and losses. Dynamic programming can help you make those investment decisions strategically to maximize your returns while minimizing your risks.
Oh, that's interesting.
Okay, I'm starting to see how this bowling problem is more than just a game. It's a microcosm of decision-making under uncertainty, where dynamic programming helps us find the most advantageous path forward. Any other unexpected applications that showcase this problem-solving power?
Another classic example that really highlights the elegance of dynamic programming is the knapsack problem. Imagine you're packing a backpack for a hiking trip.
Okay.
You have a bunch of items you'd like to bring, each with its own weight and value: a tent, food, a first aid kit, maybe even a luxury item like a comfy pillow.
But you can only carry so much weight.
Right.
It's always a struggle to decide what to bring and what to leave behind.
Exactly. And the knapsack problem captures that dilemma perfectly. The challenge is to choose the items that maximize the total value you carry while staying within the weight limit of your backpack. It's like a real-life optimization puzzle.
So it's not just about cramming in as much as possible,
Right.
but about making strategic choices to get the most value for the weight you're carrying.
Precisely. And this is where dynamic programming provides an elegant solution. It helps us systematically explore different combinations of items, considering their weights and values. By breaking the problem down into smaller subproblems, should I include this item, or does it make more sense to leave it behind? We can build up a solution that maximizes the value within those constraints.
It sounds like dynamic programming is taking on the role of a super efficient packing assistant, helping us make those tough decisions about what to bring and what to leave behind.
I love that image. And what's amazing is that the knapsack problem, while seemingly simple, has applications far beyond packing a backpack. It pops up in fields like logistics, resource allocation, and even cryptography.
Okay, I'm definitely seeing a pattern here.
Yeah.
Dynamic programming seems to excel at these optimization problems, where we have limited resources and need to make the most of them.
Right.
It's like squeezing every ounce of value out of our choices.
Exactly. And while we focused on these tangible examples, dynamic programming can also be applied to more abstract challenges. One that stood out to me from the lectures was about maximizing a mathematical expression containing both addition and multiplication.
Wait, so we're using dynamic programming to solve math problems now. How does that even work?
Imagine you have an expression like 4 plus 3, 5, 2. The way you group the numbers using parentheses can drastically change the result. The challenge is to figure out the optimal placement of parentheses to maximize the final value.
So it's like a game of strategic parentheses placement to achieve the highest possible outcome.
You got it. And it might seem like a simple puzzle, but as the expression gets longer and more complex, the number of possible parenthesis combinations explodes. Trying every combination would be a computational nightmare.
I can see how that would quickly get out of hand. So how does dynamic programming tame this combinatorial beast?
The key is to break down the problem into smaller, overlapping subproblems. We can look at each substring within the expression and figure out the maximum value it can produce, considering different parenthesis placements within that substring. Then we can combine those maximum values to find the overall maximum for the entire expression.
So it's like solving a bunch of mini maximization problems and then piecing those solutions together to find the overall maximum.
Exactly. It's a beautiful example of how dynamic programming can transform a seemingly daunting problem into a series of manageable, interconnected steps.
And this approach has real-world implications too. Think about optimizing complex systems, like scheduling tasks in a manufacturing plant or routing data packets in a network. Dynamic programming can help us find those optimal configurations, even when the possibilities seem overwhelming. This deep dive is really expanding my understanding of what dynamic programming can do. It's not just about finding the shortest path or packing a backpack. It's a powerful framework for tackling a whole range of optimization challenges.
You're getting it. And what's fascinating is that dynamic programming can be applied to problems that might not even seem like optimization problems at first glance.
Like what? Give me another one of those unexpected applications.
How about a musical example? One of the lectures explored how dynamic programming can be used to find the optimal fingering for playing a sequence of notes on a piano.
Wait, so dynamic programming can help pianists choose the best finger placement? That's incredible. How does that even work?
The idea is that some finger transitions on the piano are easier than others.
Okay.
Some finger combinations might be more comfortable or efficient for certain sequences of notes. Dynamic programming can help find the fingering that minimizes difficulty or maximizes smoothness, depending on the desired musical effect.
So it's not just about hitting the right notes, but also about finding the most elegant and effortless way to play them.
Precisely. They start by defining a difficulty function that quantifies the awkwardness of different finger transitions. Then, dynamic programming helps find the fingering that minimizes the total difficulty for the entire sequence.
It's like having a computer analyze the musical score and then guide your fingers towards the most graceful and effortless execution.
That's a beautiful way to put it. And it highlights how dynamic programming can be applied to problems that involve sequences and optimal choices.
So from financial investments to piano fingering, dynamic programming seems to be this versatile toolkit for navigating complex decision landscapes. Are there any other examples where it's used in surprising ways?
Let's explore a few more before we wrap up this deep dive.
You mentioned a connection to Tetris earlier.
Yeah.
Could dynamic programming actually help you become a Tetris master?
Believe it or not, one of the lectures did explore a simplified version of Tetris where the goal was simply to survive as long as possible, given a predetermined sequence of falling blocks.
So instead of trying to clear lines and rack up points, you're just focused on not letting the blocks stack up to the top.
Exactly. They added some constraints to make it more manageable for a dynamic programming approach, like a fixed board width and no line clearing.
Okay.
But it's still a tricky puzzle to solve.
I can imagine. So how do you even begin to apply dynamic programming to a game as chaotic as Tetris?
It all starts with defining the right subproblems.
Okay.
In this case, it involves considering suffixes of the sequence of Tetris pieces and the current state of the board.
So instead of looking at all the pieces at once, you're focusing on how to best play the last few pieces, then the last few before that, and so on, taking into account the current arrangement of blocks.
You got it. It's like analyzing the end game and working backward, figuring out the best moves to avoid getting stuck. Dynamic programming allows us to explore different placements for those remaining pieces and determine which sequences lead to a survivable state.
So it's like having a Tetris strategy guide built into the game, showing you the optimal moves to stay alive as long as possible.
Precisely.
Yeah.
It's a fascinating example of how dynamic programming can be used to navigate complex dynamic environments, even in a game as seemingly random as Tetris.
These examples are really stretching my understanding of dynamic programming. It's amazing how it can be applied to such a diverse range of problems.
I'm with you on that. It's incredibly versatile. Now, are you ready for a real mind bender? The lectures also touched on applying dynamic programming to Super Mario Bros.
Wait, Super Mario Bros. As in the classic platformer with jumping Koopas and warp pipes. I'm having trouble picturing how dynamic programming fits into that world.
I know, it sounds crazy, right? But the lecture explored a theoretical scenario where the goal was to maximize the score or minimize the time to complete a level in a simplified, static version of the game.
Static meaning no moving enemies or platforms. So it's like playing Super Mario Bros. On autopilot.
Exactly. They also limited the screen size to keep the problem manageable. With these simplifications, they were able to define subproblems like how to play the game from a specific position onward, given the current state of the visible game world.
So it's about analyzing each snapshot of the game and figuring out the best sequence of actions, jump, move left, move right, to achieve the desired outcome.
You nailed it. By representing the game world as a grid and exploring different action sequences, dynamic programming can guide Mario towards the highest score or the fastest completion time.
That's incredible. It's like having a Super Mario speedrunning expert built into the game, showing you the most efficient path to victory.
It really highlights how dynamic programming can be used to navigate and optimize within complex dynamic environments, even those as whimsical as the Mushroom Kingdom.
Okay, we've covered a lot of ground in this deep dive.
Yeah.
From Fibonacci sequences to shortest paths to even Super Mario Bros. Dynamic programming seems to have its fingers in just about every pie.
It's been quite the adventure. And I think the key takeaway here is that dynamic programming isn't just a set of algorithms, but a powerful problem-solving paradigm.
So it's not about memorizing specific formulas, but about understanding the core principles and applying them creatively to a wide range of challenges.
Exactly. It's about recognizing patterns, breaking down problems into smaller pieces, and building up solutions step by step. It's about having a framework for tackling those seemingly impossible problems and knowing that dynamic programming can often provide a clear and elegant path to the solution.
And as we've seen today, it's a journey that can lead us to some truly unexpected and fascinating destinations. Thanks for taking this deep dive with me. I feel like I've gained a whole new appreciation for the power of dynamic programming.
It's been a pleasure exploring these concepts with you. Remember, the world of algorithms is vast and always evolving, so keep that curiosity alive and never stop exploring.